Okay boys, the third and final clip on simultaneous equations is about how to use matrix methods to solve simultaneous equations. Now the problem I've got up here we saw in an earlier clip on under the elimination method, but I want to show you how we can solve the same set of equations by using matrix methods. Now we've been through the theory in class, I don't really want to go through that at the moment. But sufficient to say at this stage that these are the four main steps involved. We've got to form a matrix which we call matrix A. And then we find the inverse of A, that's step 2. Step 3 is simply to multiply the inverse of A by B. And by B I mean the matrix formed by using our constants there. And then finally, a very minor step, we state the answer. So here I can say that matrix A is equal to, simply record the coefficients of x and y, making sure that your x's and y's are properly lined up. So if they're not, you're going to have to rearrange your formula a bit, your equations a bit. So we go 2, -3, 5, 2. And hopefully you can see where those numbers are coming from. And while we're at it, we're going to record what B is. It's just a column vector, a fancy name for a one column matrix, and that's 5 and -16. Okay, so step 1 was to find A. Now step 2 really is to find the inverse of A. Now remember what the inverse of a matrix is. I'm going to put it in general form so that you have a permanent record, because this bit is quite important. So if I've got a matrix A that's just expressed like this, A, B, C, D, the matrix, the inverse of A is quite simply 1 over the determinant, so I could say det A under here, but instead of that I'll show you how to calculate the determinant. It's A times D minus B times C, so the product of one diagonal, subtract the product of the other diagonal, and then we switch matrix A a bit so that we've got D in that cell, A in that one, so we switch the numbers in that diagonal. We leave the other diagonal as is, but we just change the signs of whatever the numbers are. Okay? So that's how you're going to find an inverse. I remember it as a process more than a lengthy equation like I've shown there. Okay, so let's find inverse of our current matrix. Right, so A, the inverse of A is equal to 1 over. So it's going to be, I'll put the numbers in so you can see where they're coming from. It's AD, so it's 2 times 2. Subtract. Brackets are handy here. What have I got? -3 times 5. Close brackets, and then I switch my cells. So the 2's, well, that's not going to have any effect because that's both 2 in that diagonal, and then I simply change the signs of the cells in the other diagonal, like so. Okay, so let's tidy that up before we do the actual multiplication. The inverse is equal to 1 over. Now it's going to be 4 minus something, okay, minus -15. So that means 19. So it's 4 plus 15 really, isn't it? So it's 19. Okay, so, and I don't have to do anything to this matrix here at present. Okay, so what I've got to do is multiply that inverse by B. Let's find some room for ourselves and proceed. So therefore, now we can say x, uppercase X, but we can write it as that vector, like so, equals 1 over 19. This is step 3, by the way, like so, times B, and we said B was 5 and -16. Now this 1 over 19, which we call a scalar, we're going to leave it out there. It's not going to be terribly convenient to multiply everything in here by 1/19th, is it? So we can just multiply that matrix by that matrix. Okay, and leave the 1/19th where it is for the moment. Okay, let's do that. Now remember that I've got a little saying, when you're multiplying matrices, it's row by column, row by column. So what that means is that here, I'll just highlight it, it's going to be 2 times 5 plus 3 times -16. I'll write in the working out so that you can see where everything's coming from. So 2 times 5 is 10, oops, and then what have I got? Plus 3 times -16, so it is -48, minus 48 I should say, and then -5 plus 5 is, times 5 is -25, and then 2 times 16 is minus 32. Okay. All right. Where do we go to from there? Well, we just got to tidy up that. We've just got to tidy up this bit here. So x. Oops, done it again. Therefore, xy equals 1/19. Now, what have I got here? -38 and -67. Sorry, 57, is it? Yeah, 57. Okay. Now what we can do is deal with the 1/19th. So that's quite simple. Now, therefore, xy 1/19th times -38 is -2, and 1/19th of 57 is -3. So that's our answer, fellas. If you want to, you can write it as a pair of coordinates, remembering y, and you should find that that's the answer we got in the previous clip. So that's how you solve simultaneous equations using matrix methods.